Hey, good morning. How are you? In this short tutorial, I'm going to show you how to use the SolidCAM that I got from the website, from the SolidCAM website, in case if I don't have the access to uh, the VMware or the call it Spacework through the UTS website. So as you can see here, I got this version of the SolidCAM 3 days ago. Now I only have 57 days left, and I will press that I want to keep using the trial version, say finish, and you will see that actually the, the icons we're going to have here is going to be quite different from the one we had in uh, the one the SolidCAM 18. Actually, not SolidCAM 18. The full version have the 3D milling. This one doesn't have 3D milling. So I made actually a simple part, and I'm going to try to show you the work on that part. Where did I save the thing? I think it was something on my download. I did that yesterday for what's this in the uni. Okay, so I will show you how to use the alternative options instead of the 3D milling that you cannot find in the trial version. Just waiting for the part to load up. Okay, so the part is very simple, as you can see here. I add some common things like, for example, the internal spherical shape, cutting from the side to lower the level. We have a slot. I think that is going to be a good idea if I'm going to add a drill here. So I'm going to sketch on that surface. I'm going to make just a hole. So I will have a hole in maybe in this point. I'll try to make the hole have the radius of 5 millimeter. Or diameter of 10 millimeter in that case, just to be sure that's going to be 5, yes. And I'm going to take this one um, to a lower level. So I will do the extrude cut, and I'm going to take it to 10 millimeter because the total is 20, so I'm going to take it to 10. That's one thing. And the other thing is I'll try to make the step hole, which is going to have two diameters. And in that case, I will make this one aside. So both are going to be the same process. So I'm going to sketch here, and I'm going to make a circle. Choose the thing. Okay, so I'm going to make this another hole here. In this hole, I'm going to have the outer radius to be 7.5. 7.5. That means diameter is going to be equal to 15. Uh, oh well, no, I should do the 10 millimeter first, then the bigger one above that. So here we're going to have the 5 for the radius. Say OK, features, extrude cut, and I will take this one to 10 again. And then I'm going to go back, make another sketch. And here I'm going to click on this circle and just do the offset. My offset is going to be by 2.5 from one side. And this will make the radius of the yellow circle here to be 7.5, or the diameter is going to be 50 millimeter. Okay, and for this one, I'm going to do the extrude cut, and I'll try to take it to the height of 5 millimeters only. And we're going to end up with having the step hole. So you can see that we're going to have two levels for the hole. And I'm going to start to do the machining for this part by using the trial version of the SolidCAM. So first I'm going to save this part, and second I'm going to do the solid part. So SolidCAM, once again, I downloaded from the website. I'm going to show you where the website is. You need to create an account, and from this account you can download the trial version for education. SolidCAM for education, that's what you're going to search for, and it will take you to the website, and you can simply download from trials, trial for free. That's where I get the copy from. And as normal, I simply just click here on the add-ins, and I defined that I would like to use the SolidCAM 2020. Okay, now very important points. Sometimes when you try to do the SolidCAM, it will give you an error message. The first message is going to be that, for example, that the part sketch is not available. And the part sketch is not available, just simply save as the part in different directory under different name, and it's going to work. The other problem you may have is that it tells you that the software is not working properly. Like, for example, the machining operation does not exist. Now, to set up the SolidCAM before you're going to start to do the work will depend on where are the files has been installed. So if I'm going to go to my C, usually all the well, I'm going to show you that step by step. So if I'm going to go to SolidWorks, and here I'm going to go to Tools, and go to the SolidCAM, go to the SolidCAM setting, you will have the page. Oh, it's coming soon. I don't know why it's not coming. Yep, it's went to the other screen. We'll get this. Okay, now I'm sorry, my computer is playing full. It's a mouse thing. Okay, it's done by itself actually. I hadn't moved it this way. Yep. I don't know why it's floating. Yep. Okay, so if you would like, by default, everything will be installed on the C, but many of the people having this C as the solid state, and they use it to install the Windows version, like mine, for example, and it's going to have a smaller size. For example, my laptop is from 2016 or 18. I don't remember, but in all the cases, the solid state at that time had the maximum value of 150 gig for the storage. So I use this one only to install the Windows, and every software I put on the. By default, the SolidCAM or the SolidWorks, especially SolidCAM, is not going to ask you for the directory. It's going to send it to the C directly. So you need to change the location manually to the D, and that's what I'm done here. So I'm going to show you how we do that. You will find the installation files on the C. You go to the users, and in the user you will find the folder in the public called the SolidCAM 2020. You just copy this link, copy this file, and you go to the D. You will find the users. For example, that's what I have. Or you don't have it, just create one. I put it under Ahmed, and I pass it here, SolidCAM. And I have the SolidCAM 2020 within, and I have this folder built in. Now, I know where it is right now. I'm going to change the directory of these files, like the directory of the CAM parts, the directory for the system additional files, the Excel file for the thread tables, which is an Excel file, and the iMachining database. So you can see that what we're having here was the, oops, it's gone, sorry for that. It's sliding very easy. Oh, sorry. Okay, so I will need to read down here what's written, and then I try to search it and compare it to these files. For example, I will have the GPP tool. I have the tables where you can find the metric here, the one we're going to use. We have here the threading standard for the metric, which is going to be this one. And after reading what's written here exactly, so this one, for example, is going to be the user. This one is going to be for the tables metric. This one is going to be for the Excel sheet or the metric standard threading metric. And this one is going to be for the database. So simply we just click here and we go to the D and find it within the directory, user Ahmed SolidCAM 2020, and I will get the iDatabase for this one because that's what's meant. Well, that's how it was before I changed the directory iDatabase. Now, same thing here. I'm just going to take you to the folder with the SolidCAM 2020 on my directory. Another thing is going to be for the machining. So we go here to this list on the side, and I'm going to do the part of default CNC controller. And once again, I need to change this directory to go to the GPP tool folder. So I'm just going to choose the GPP tool folder, and then all the directories are going to be changed to the default value of, like, for example, the 1000 FANOC, we have the OCaml, and we have the DMU AT.MT and the Makino. So everything here will be setting up the system for you to work properly without any problems. Now we go back to here. I hope that the thing will work directly. So I go to the SolidCAM part, and again to make a new milling operation. And by the way, you have the chance to try the turning if you want. I'm going to try to make a tutorial for the turning later. First, I don't know why my screen here turning black, but anyway, I'm going to use the external. I'm not going to change anything here because it's already been set by default. Say OK. I got the part. Now that's means that the software is working without any troubles. And then I will start the steps of choosing the stock. So selection of the mod of the part, click anywhere. Say OK. You remember that we're supposed to take this size to the 0. I'm not bothering with that now. Here we are going to choose the highest face we are going to have for the work part. So I'm going to click on here, and this will create the datum point by default to this side. As I told you, once again, you can change that. You can change that. You can define selection of coordination system, the normal to the current view, or by 3D points if you would like. Choose which point is going to be your, which one on the part is going to be your datum point. Anyway, I'm satisfied with this one. I'm going to say OK, and then continue with the setting up until they're going to have the part ready for me. Okay, now still working. By the way, I pressed SolidCAM operation, but it's going to take me to the same thing. It doesn't matter. Okay, now we are here. And the first thing we are going to do is select our tools. So let's try to analyze the part and what do we have as tools. We have 15 millimeter diameter here. We have the 10 millimeter diameter, 10 millimeter diameter. This slot have the width of 15 millimeters, and here we have a spherical shape, and need to have something called the ball nose or the lollipop cutting tool. Either it's going to generate the spherical shapes. So I'm going to define my tools. The first tool I'm going to choose is going to be the 15 millimeter diameter that's going to be able to remove the material from these sides at higher rates. So my first tool is going to be the end milling, the one which have the flat end. And here I'm going to change the diameter to 15. So click on the next one, changing everything. Okay, so I'm going to save and make another tool, add another one. The other one is going to be the 10 millimeter diameter. So change that to 10. Say OK. Okay, and save and add another tool, which is going to be the ball nose. And I'm going to leave it, I will make it 5 millimeters. This will be fair and good to give me a good surface finishing. And just remember that the cutting is going to be from this side and the center, not like the flat head for the face milling, which cutting only from the face and the vertical side. This one is going to do it on the whole radius of the cutting tool to shape the spherical shapes. So we have this cutting tool ready, save and exit, done. We define the 3 cutting tools. Now, once again, I told you that these are going to be more advanced. Like, for example, you can make a CAD model for the fixture, like the vise, to show that on the machine. We can use the type of the machine to make the simulation in 3D dimensions, well, virtual machining for the part. Anyway, this will be something that you will need to discover yourself. Now we come here adding the operation. Right click, you will see that in the list of the milling operation, we don't have the 3D milling. Instead of that, we are going to have the high speed surfacing. We have the high speed roughing, 3D high speed roughing, and the other operation like the face, the profile, the contour, the pocketing, the drilling, and the other operations. So I'm going to start first using the HSR. HSR is going to make use for this surface. Let's try to use the what did I use yesterday? This is high-speed machining, which is going to analyze the whole shape and do the cutting for you. So let's try to use the HSR. Well, I don't remember exactly what did I use yesterday, but anyway, let's try to use that. So I'm going to click on defining the target, and this is going to ask me to choose the CAD model. Let's choose the CAD model here, and say OK. The high-speed surfacing, I think, is going to be mainly doing. Well, anyway, let's try to do that. Okay, now for the tool, I'm going to choose the 15 millimeter tool, which is going to remove the material at high rate for this side. Also, I'm going to use it to do some drilling operation if possible. Now, the boundaries. It's either going to be created automatically or I can create it manually. So I will choose the manual one and I'm going to click here and try to choose what will be the first operation cutting. I think if I'm going to cut on the click on the edge here, it's going to show me this purple line. I will say yes. So I would like just to cut this part first with the to this level with this operation. So I will say okay here. Okay, let's see what the other options we have. The offset value, I'm going to leave it to 0. I will leave it as centered. I will go to the passes. Now for the passes, you can see I will leave as an offset value of 0.5. The step down, I can change the step down from here if I would like. Okay, so it's going to optimize to the Z level. So it's going to do it by itself. Okay, and let's do it right now. So I'm going to save and exit and see what will happen for this part. So I'm going to right click and calculate. It's doing the calculation here. Okay, so I'm roughing the passes, the linker, and let's see what are going to be the results here. Okay, now this will be the path to remove the material from this L shape, this side. So you can see that uh, the levels are going to be 2 each time. I can of course reduce this one to get uh, higher rate of the material removal because this one is going to be something about 10 passes or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 passes, and this will be too much. Anyway, I can change that later. Okay, so that's replace the 3D milling to remove the material from the side, the HSR or the high speed roughing operation. Now let's try to add another operation to do the cutting for the slot first or doing the drilling. Well, because I'm talking about that because in both cases I'm going to use the 10 millimeter, the 15 millimeter diameter cutting tool. So I think that the first operation I'm going to do with that is I'm going to drill this upper level of the hole. So I'm going to add the milling operation. I will go for the drilling. Okay, and I will define the drilling operation geometry. Choose the geometry. Of course, I need to remove these lines by untick the calculation for the operation. However, again, to click on that surface. So it's going to drill this first step of the drilling to the depth of 5 millimeter. So click that OK. And the tool is remain the same or the 15 millimeter diameter. Okay. Because this will be the one can give me the diameter of 15. So I can do it by the 5 by 10, for example. Okay, now the drill depth, upper level and the drill depth. Drill depth is not going to be 30. Instead of that, click on here and define that this level, this face, is going to be the depth. So it's going to be recalculated now to be 15. So it's going to start to do the movement of the cutting tool from this height until it's going to reach this level and stop. Technology is going to be just drilling default, so I don't need to do anything here. Again, to save and exit for this operation. Okay, now I'm going to untick this one because I don't want to have too many lines shown on the paper. Oh, not paper, on the screen. Setup, I'm going to do another drilling operation for these two holes to the end and doing the pocketing, and I'm going to do that by changing the cutting tool to the 10 millimeters. So once again, I will go to the drilling operation, and in that case, I'm going to define the new faces to be this one, the bottom here, and second is going to be this one. So these are the two circles I would like to cut by drilling operation. The cutting tool in that case is going to be the 10 millimeter. So I'm going to select the 10 millimeter cutting tool, which was the tool number 2. Tool number 2, 10 millimeter. Just double check that and say yes. Okay, then the levels. Now the levels, the upper level, let be 0, but the drill depth is going to be minus 20. So I'm going to click here, minus 20. The same thing for this one, just a double check. If you are going to have two different depths, so do the drilling operation separately. For example, if this depth is going to be minus 25 from this surface, and this one is going to be minus 15, do the drilling operation in two different steps. Doesn't have to be linked together. And then I'm going to save and exit, and we have the drilling operation number 2. Now I'm going to do the pocketing operation here. So I'm going to right click and I'm going to add the milling operation, and I'm going to do the pocket. Now the pocket process is classic. It doesn't have to be complicated. So just click on the defining of the surface, click on the edge here, and it's going to define the area within I would like to do the pocketing. Say OK, click here, yes. The tool is going to be the 10 millimeter, the same cutting tool, which is tool number 2. Okay, and the levels is very important. The pocket depth is already been defined to be 10, which is correct. The upper level is going to be 0. Anyway, you can simply click on that and select the depth once again, but it's going to be minus 10, which make the depth of the pocket to be 10 millimeters as we had earlier. And the operation will be by contour. So the cutting tool will start to moving in curves to remove this material. I can set the minimum overlap to be 50% of the tool of the diameter. I think if I'm going to use the 15 millimeter diameter, if I'm going to set this one to 0, so then the cut will be from one side to another. We can give it a try later. And the removing of the layers, I think we can do that from the levels. The upper level, yeah, the step down is going to be 5 millimeter each time. So each time is going to remove 5 millimeter of the thickness. Now we finish with this one. I'm going to save and exit. And the last one is going to be that phase. So how to do this one in easy process. Instead of adding the milling, I will add the HSS. What did I use here? The HSR. Yeah, I'm going to use the HSS, which is the high speed surfacing. So let's go with this one, HSS. And you can see that it's going to do the contour faces. So again, no need to change this one. Coordinate system doesn't have to be changed. The geometry. So again, to dry surfaces, I need to choose a surface here. So again, to click on that. It's been defined as the one is going to be analyzed by the operation. Now, the most important thing here is choose the correct tool. So this tool is going to be tool number 3, which is going to be the ball nose. So tool number 3, just remember this one is going to be the ball nose. Check that. Okay, say yes, and then we're going to go to the levels. It's going to be done automatically, so I don't have to worry about that. The toolpath parameters. Now, it doesn't matter for me for the surface quality is good. I can make it better. I will take it with the 1 in the 100. And here will be the most important thing, which is going to be maximum steps over. So I will leave that now as 1 millimeter. So the distance between one movement to another is going to be 1 millimeter. I will leave it as it is. And again, to start to do the calculation for this operation. So this will be the last operation. I'm going to do the calculation for, and it's going to show me the toolpath uh, movement. So as you can see here that this will be the retract movement, and the toolpath is going to be in this green line. So it's going from one side to another. The distance between the gap between these lines is going to be equal to 1 millimeter. And this will show me the following. By doing this simulation and try to check what will be the quality of the part we are cutting by checking the rest of the material, you will see that it's going to be actually quite bad. Uh, it's not showing right now. Anyway, it's going to be because this is the last operation. I should do the calculation for everything here to show the this one. Anyway, the best way to do that to get the best of finishing is doing the editing and try to minimize the value here for the maximum step over. Well, actually, I find that if we multiply that by 10, this will give us the best uh, resolution. So again, to save and exit, and you will see that the calculation now showing that the lines are going to be 100 times instead of 10, and this will achieve me the best resolution I can have for the surface finishing for this part. Now, if I going to do the calculate all, okay, is going to show me the total lines for the cutting operation to finish with the work. Okay, so actually I got a message and I got an error message here. It says radius length will be automatically set to the maximum value. Say exit as long as it works, so it doesn't matter with me. So you will see that we are going to do all the steps of the removing of this level. Then we're going to do the step drilling for the first depth. Then we're going to do the total depth of the drilling operation. We do the pocketing using the 10 millimeter diameter cutting tool. Then I will choose the lollipop to make this vertical shape in. I don't want to run any simulation now because it's going to take forever and I have session in 5 minutes. Anyway, the other step you need to show me is, and if in case if you are going to using this version, you will see that we cannot generate the G code, but you can simply just show me that in the video that to generate the G code, we go to G code all and generate. The file name is going to be set up, and you will see that it's going to give me a message that this version is not able to do the machining operation after we finish this calculation. Anyway, just show me this step as a proof that, oh, wow, it's worked. That's funny. So it's worked and generating the G code. If you are going to generate that, you don't have to copy and paste that on your assignment paper because this will be something about 1,000 line. Instead of that, just save it and try to attach it to your. Oh, I think you cannot save it now. Save as. Ah, you can save it. Okay. You can show me that. Okay, now these are the steps, and I will believe that you know how to do it. Okay, so I think that's all, and again to be with you on Friday, and we are going to answer your questions if you still have any for using the CAD/CAM operation.